Welcome back. So we are continuing to graph rational functions where the numerator, the denominator, or both have terms raised to a power. Right, so here's our steps for graphing this rational function, f of x equals x squared minus 4 divided by x squared minus 9. So our first step is to factor. Now this is an easy factoring because it's a difference of squares. We have perfect square minus perfect square. X squared is a perfect square, 4 is a perfect square, 9 is a perfect square. Right? And it's a difference of squares because it's perfect square minus perfect square. And these always factor the exact same way. So it's going to be f of x equals square root. So square root of x squared is x minus square root of 4 is 2, square root plus square root. Right? So they always factor the exact same way, so they make it really easy to factor. Right? So x squared minus 4 factored is x minus 2x plus 2. X squared minus 9 factored is x minus 3x plus 3. Right, so we set each factor of the denominator equal to 0. Those are the vertical asymptotes. Right, so if x minus 3 equals 0, x equals 3 is one vertical asymptote. If x plus 3 equals 0, we subtract 3 from both sides. X equals negative 3 is the other vertical asymptote. Horizontal asymptote is determined by the degree of the function. Right, so let's find the degree of the numerator and the degree of the denominator. So the leading term in the numerator, it's the term with the largest exponent, and the only x is x squared. So that is degree 2 because it's raised to the second power. And in the denominator, we also have a leading term of x squared. So again, degree 2. So now, well, 2 equals 2. So the degree of the numerator equals the degree of the denominator. If the degree of the numerator and denominator are the same, it's going to be the ratio of the coefficients. If there's no coefficient, it's understood to be 1. So the horizontal asymptote is going to be y equals 1 divided by 1, which is just y equals 1. That's the horizontal asymptote. So we found the vertical asymptote. We found the horizontal asymptote. On the big space here, let's find the x and y intercepts. Okay? And then we'll plug in some values between all of our vertical asymptotes. So we need at least 3 in between the two vertical asymptotes and at least 2 on either side. Right, but let's find the x and y intercept because that can be part of our points, right? Part of our 7 to 9 points. So if we set the function equal to 0, 0 equals x squared minus 4 divided by x squared minus 9. Remember, you can also do this the short way, just set the numerator equal to 0, because you notice again that denominator is just going to cancel out because a fraction is equal to 0 where the numerator equals 0. But you don't have to show all the work. I'll still show the work just to make sure it's clear that our x-intercepts, I should have labeled this x-intercepts. Our x-intercepts are going to be where the numerator equals 0. Now we have already factored this, and we probably should have used the factored version. Actually, so let me do that. I don't know why I took the other version. So 0 equals x minus 2, x plus 2. So notice that, when I still forgot to label it, x-intercept. There we go. X-intercept. All right, so notice that if we cross multiply, right, we have one product that's always 0. And it's always the denominator times 0. So really, we could just set the numerator equal to 0, and that would give us the x-intercept. So I just wanted to make sure that that was clear for everyone, that our x-intercepts occur where the factors in the numerator equal 0. Right? And that's because you take 0 times anything, you're just going to get 0. All right, and a fraction is equal to 0, where the numerator equals 0. So we have two x-intercepts. If x minus 2 equals 0, x equals 2. If x plus 2 equals 0, x equals negative 2. So our two x-intercepts are 2, 0, and negative 2, 0. And those are actually really nice points. So we now have, out of our 7 to 9 points, we've already got 2 of them, just by finding the x-intercept. Now to find the y-intercept, you just plug in 0 for x. So f of 0 equals 0 squared minus 4 divided by 0 squared minus 9. Well, that's just going to give us 4/9, right? And it's going to be negative 4 over negative 9, which would just be 4/9. So let me just label this. This is the y-intercept. So we have another point, our y-intercept, when x is 0, y was 4/9. So now we have almost a half of our points, right? Depending, if we're going to graph 7, we've got almost half. If we're going to graph 9, we've got a third. All right, so let's remember those points, and we're going to put them in a table of values on the other page. Right? So make sure, so by the way, make sure this part's in your note. No, sorry, this one is not in your notes. Never mind. So just follow along and enjoy. This problem is not in the notes. All right, so let's write down our vertical asymptote and horizontal asymptote and the points we found so far. So two vertical asymptotes, x equals 2, and x equals 3, and x equals negative 3. And then let's just graph those right away. There is the two vertical asymptotes. There's x equals negative 3, and here is, I guess I leaned a little bit. And here is x equals 3. And then we found, and let's graph our horizontal asymptote. That was y equals 1, the ratio of the coefficients, because the numerator and denominator are the exact same degree. There we go. All right, now we just need our table of values. And we've already found, we found all 3 points that we needed in between the two vertical asymptotes. Right? Because we know that when x is negative 2, y is 0, because that was an x-intercept. When x is 0, y is 4/9, because that's a y-intercept. And when x is 2, y was 0, because that's another x-intercept. So those are our x and y-intercepts. We need two values that are less than negative 3. So let's stay close to the vertical asymptote and choose negative 5 and negative 4. Right, so we have negative 5 squared minus 4 divided by negative 5 squared minus 9. So we just plug the values in. Right, so we just want them on either side of the vertical asymptote. We already found our x and y intercepts. That gave us 3 points. And now we're going to plug in two values that are less than negative 3 and that are greater than positive 3. Okay? And then we'll have points on both sides of each vertical asymptote. All right, so this would be negative 5 squared is 25. So this is 25 minus 4, that would be 21. And 25 minus 9 would be 16. So 21/16, so 24/16 would be 1.5. So it's just a little less than 1.5. If we plug in negative 4, we get negative 4 squared minus 4 divided by negative 4 squared minus 9. So negative 4 squared is 16. 16 minus 4 is 12. And 16 minus 9 is 7. Okay? So if that were 14/7, it would be 2. Right? So it's a little less than 2. And then we have those values already. So now 4, this would be 4 squared minus 4 divided by 4 squared minus 9. Well, whether we square 4, negative 4, or we square 4, we're going to get the same thing, right? So this is also going to be 12/7. And the same thing is going to happen when we square 5. 5 squared minus 4 divided by 5 squared minus 9. is going to give us 21/16, because it doesn't matter whether we square a positive number or a negative number. We're going to get the exact same thing. So this is one symmetric graph. All right, at least to either side of the vertical asymptotes. All right, so let's graph our points. We have -5, 21/16. And that, by the way, so 12/7 is closer to 2 than 21/16 is. 21/16 is less than 1.5. So it's going to be about here. Right, 12/7 is almost 2. So that's just a little bit more. Right? And we're going to have the exact same thing on the other side. Almost 2 and a little less than a half. Or excuse me, a little less than 1.5. And that could be just a tad lower. Of course it won't move. Well, maybe we're going to decide that that's probably good enough. I think that's, that's close enough. Because that point is just not going to move. All right, so to the left, we cannot cross that vertical asymptote. No way, Jose. And we will not cross the horizontal asymptote. So if a function is going to cross the horizontal asymptote, it does it very close to 0. And I just missed that point. I guess that's good enough. I guess that's close enough. And then over here, it's hard to be exact when I'm drawing on a big board. So we cannot cross the vertical asymptote, and we will not cross the horizontal. Actually, it's not too bad. And now we need the values in between. So we have -2, 0, 2, 0, and 0, 4/9. So that's just about a half. Now, if you look at that, they're not forming a diagonal line. So that is not going to be shaped like an S. That's going to be shaped like a U. And this is a very symmetric graph. We have the same thing to the right and to the left. And we have the same thing in between. We have sort of this symmetric U in between, right? And probably that is because we have squared terms in both the numerator and denominators. Oh, let's see if I can fix it. I went up too high. Well, that looks pretty good. We'll take it. Now I'm too close to the vertical asymptote. All right, let me try to draw that one more time. I'll do better this time, I promise. If I can get rid of it. All right, let's try it again. All right, we won't cross the vertical. And we're going to go to the x-intercept, the y-intercept, the other x-intercept, and then we're going to try really hard not to cross the vertical asymptote. That's pretty good. All right, and there's our very, very symmetric graph. All right, all we need is domain and range. All right, so for the domain, we need to take out the vertical asymptote. So that would be -∞ to -3. So we're skipping over -3. -3 to 3. We're skipping over 3. Just imagine me skipping, all right? I'm just jumping right over that value because we can't use that value, right? Because that would make our denominator 0. So everything as close as we can get to -3 is good, but not -3 because it makes the denominator 0. And everything as close to 3 as we can get is good, except not 3 because it makes the denominator 0. And then 3 to infinity. Right? And now the range, we have to look at the graph. Well, notice that it's in the middle there, it's going to keep going down to infinity. So our low value for the range is infinity. Notice the graph turns around. And it turns around at that y-intercept of 4/9. So this is why I said it's really important on the range to look at the graph. So it goes from -∞, this is very symmetric, right in the middle between the two x-intercepts is the y-intercept, and it turns around. It's like a little vertex, sort of. And the graph does not pick up again, right? It doesn't pick up right after 4/9, right? It doesn't cross. Matter of fact, this graph does not cross the horizontal asymptote. It doesn't pick up again until the horizontal asymptote. And actually, let me fix one thing on this range here. And the one thing is that the function does go through the 0.49. So because it does go through that value, we'll use a bracket. Right? And then we'll have a parentheses because the graph does not cross the horizontal asymptote. So 1 to infinity, and there we go. The last little part is let's put in the end behavior. So this is a little bit long because now we've got a lot of pieces. So it would be f of x approaches 1, the horizontal asymptote, as x approaches negative infinity. And then f of x approaches, so as we get to the first vertical asymptote, it approaches infinity as x approaches negative 3 from the left. The graph approaches negative infinity as x approaches negative 3 from the right. So as we look on the right-hand side, it's going to negative infinity. It also approaches negative infinity as x approaches 3 from the left. That whole middle section is approaching negative infinity. And then f of x approaches infinity as x approaches 3 from the right. So at the vertical asymptotes, it has to go to infinity or negative infinity. And then as x goes to infinity, the function approaches the horizontal asymptote, which is 1. So f of x approaches 1 as x approaches infinity. And there's all of our end behaviors at both of the asymptotes. All right, so now let's go on to the next one. That one took us a little while. I don't know why. It was a pretty easy graph. It's got to be me. Well, we're going to do 3 graphs. So that was number 1. Number 2, this one is in the notes. So y equals 2x cubed divided by x cubed minus 1. We'll factor first when we can, but if you have something quadratic, you'll factor. If you have something cubic, chances are you probably won't be able to factor it, particularly if it's just something like x cubed minus 1. And we've actually seen at least something very, very similar to this one. So on this one, we're not going to be factoring, so because we have a cube here that we could just take a cube root of both sides. So we have x cubed minus 1 equals 0. We're going to set that denominator equal to 0. Add 1 to both sides, so x cubed equals 1. We'll take the cube root of both sides. Remember, there's no plus or minus when it's an odd index because there's only going to be one solution. And the cube root of 1, of course, is 1. So we have a vertical asymptote at x equals 1. For the horizontal asymptote, let's look at the degree of the leading term in the numerator and the denominator. So the leading term in the numerator, of course, is the only term in the numerator, is 2x cubed is our leading term, right? And that degree is 3. Right? Because it's x cubed. The leading term in the denominator is x cubed. Right? And that is also degree 3. So, of course, 3 equals 3, so the numerator and the denominator are the same degree, so it's going to be the ratio of the coefficients. So that's understood to be 1. So the horizontal asymptote will be 2 divided by 1, which is 2. Right, so we have 1 vertical asymptote at x equals 1, 1 horizontal asymptote at y equals 2. Right, now let's find the x and y intercepts. And actually, we're going to have the same value for the x-intercept and the y-intercept. And I'll show you just so you can see that. I'm going to do this the shorter way, and I'm just going to set the numerator equal to 0. I think you probably have the hang of that. So if 0 equals 2x cubed, if you divide it by 2, you'd have 0 equals x cubed. And of course, if you take the cube root of 0, well, that's just 0. Our y-intercept, you see, is the exact same thing, because if I plug in 0 for x, I've got 2 times 0 cubed over 0 cubed minus 1. Well, that's 0 over negative 1, and 0 in a numerator means that equals 0. And that makes sense because we got 0, when we plugged in 0 for y, we got 0 for x. So obviously, the x and the y-intercept are 1 point, and it is the point 0 of 0. All right, so that's 1 point. We only have one vertical asymptote, so actually we only need 4 points. Right, so 4 to 6 points would be fine. And we've got one of them, 0, 0. Let's graph the vertical and horizontal asymptote. So vertical asymptote is x equals 1. Horizontal asymptote is y equals 2, the ratio of the coefficients. Maybe I should write that in too. This is y equals 2, and this is x equals 1. This is actually going to be a pretty fast graph. So we need two values that are, at least two values that are less than 1. And we have one of them already, 0. Right? We plug in 0, we get 0. And so let's take negative 1. Right? And if we feel like we need more values, then we'll plug some in. Like, so if it seems like we're a far distance from our horizontal asymptote to make sure we graph accurately, then we'll plug in more points. All right, so we have 2 times negative 1 cubed divided by negative 1 cubed minus 1. All right, so negative 1 cubed is negative 1, so 2 times negative 1 is negative 2. Reminder, this one is in your notes. Negative 1 cubed is negative 1. Negative 1 minus 1 is negative 2. And so that is 1. All right? Let's graph actually one more point. So let's graph negative 2, just so that we have 1 point just a little closer to the horizontal asymptote, since we're 1 away right now. All right, so this would be 2 times negative 2 cubed divided by negative 2 cubed minus 1. Negative 2 cubed is negative 8. 2 times negative 8 is negative 16. Negative 2 cubed is negative 8. Negative 8 minus 1 is negative 9. All right, so this is 16/9. That is a little less than, hey, wait, is something wrong there? A little less than 2. Should we? Oh, yeah, that would be closer. Sorry. I'm forgetting. Our horizontal asymptote's at 2. Yes, so we're closer to 2 now. All right, so now we've got 3 values. Let's plug in 2. We need the 2 values that are greater than 1. So let's do 2 and 3. And if we think another value would be warranted, we can plug in 4. Let's see what we get, though, first of all. 2 times 2 cubed divided by 2 cubed minus 1. So 2 cubed is 8. 8 times 2 is 16. And 8 minus 1 is 7. So 16/7, a little more than 2. I think that'll be fine. And then 3, we have 2 times 3 cubed divided by 3 cubed minus 1. 3 cubed is 27 times 2 is 54. And then 27 minus 1 is 26. So these are both a little bit more than 2. Because 52/26 would be 2. And I think that's going to be close enough because we're not even a whole unit away. So I think that will be fine. Let's graph our points, right? So we found 5 points, right? And we'll graph them. All right, so all I got to do is graph the point negative 1, 1. That's right there. 0, 0. And then we have negative 2, 16/9. Well, 18/9 is 2, so this is a little less than 2. About there. Right, on the other side, we have 2 16/7. Right, so 14/7 is 2, so that is a little bit more than 2. Not even 2.5. 54/26 is even closer to 2. Because 52/26, we're just 2/26 away from being 2. So that is pretty close to 2. Right, so on the left-hand side, we'll not cross the horizontal asymptote. Oh, and most of the time, these cubic ones don't. It's those ones that are squared. Oh, that was just terrible. Let me back up a bit, and I think I'll be okay. Yeah, that's pretty good because that points a little bit. Let's see. There we go. That looks pretty good. Other than the little, it's supposed to be getting closer, not farther away, but you know, sometimes when you're drawing on this big smartboard, there we go. All right, so there's the left-hand side. The right-hand side will not cross the vertical asymptote. Cannot cross. And it will not cross the horizontal asymptote. And there we go. That's all there is to this one. Looks a lot like the ones we've done earlier, right? Except it goes faster to the asymptote. And that's because we're cubing. All right? Domain and range. Domain is just going to be everything but the vertical asymptote. So negative infinity to 1, 1 to infinity. And the range, it did not cross the horizontal asymptote. So everything but the horizontal asymptote. Negative infinity to 2, 2 to infinity. So these cubic ones look an awful lot like the other ones. But they're gonna head to the asymptote faster. So we need to make sure we've got an accurate table of values to show that. And then the last thing, let's do end behavior. So f of x approaches 2 as x approaches negative infinity. F of x approaches negative infinity as x approaches the vertical asymptote from the left. F of x approaches positive infinity as x approaches the vertical asymptote from the right. And f of x approaches the horizontal asymptote again as x approaches infinity. All right, so as we approach the vertical asymptote from to the left and to the right, we're going to go to negative infinity or infinity, respectively. And as the function approaches as x approaches negative infinity or positive infinity, the function is going to head to the horizontal asymptote. So this is the end behavior. Okay. And we did the domain and we did the range. The range is just up a little bit. There we go. All right, and so this one should be in your notes, and I have one more, and that one is also in your notes. And this one's going to have 2 vertical asymptotes. All right, so we have y equals x squared plus 2 divided by x squared minus x minus 6. Now, on the factoring, there's nothing to factor in the numerator because the numerator is a sum of squares, but we could factor the denominator. Right? That's just review factoring. So a equals 1, that's the coefficient on x squared. B equals negative 1, and c equals negative 6. 1 times negative 6 is negative 6. So we need 2 numbers that multiply to give us negative 6. That's the a times c. But add to give us negative 1, and that's the b. And hopefully, you right away, you are thinking negative 3 times 2 is negative 6, and negative 3 plus 2 is negative 1. All right, so to factor, we keep the x squared. We replace the negative x with a negative 3x and a positive 2x. And we keep, oops, I'm too close to the recording box. So it won't let me write. There we go. Now I just moved it. There we go. And then the first 2 are a group, the second 2 are a group. Plot the greatest common factor, so we could factor out an x. X squared divided by x is x. 3x divided by, technically negative 3x divided by x would be negative 3, or x minus 3. Greatest common factor for 2x and negative 6 is a positive 2. 2x divided by 2 is x, and negative 6 divided by 2 is negative 3. So notice they match. We can factor out that repeating x minus 3, and we're left with the leftovers, x plus 2. And we want to, actually, I'm sorry, we are going to set these equal to 0, but we're going to rewrite it first. So I'm not going to bother to put that equals 0 up here. So we're going to, first of all, rewrite this as y equals x plus 2 divided by x minus 3 times x plus 2. For the vertical asymptotes, we're going to set the denominator equal to 0. So we have x minus 3 equals 0, x is 3 is 1. If x plus 2 equals 0, x equals negative 2 is the other vertical asymptote. Let's find the horizontal asymptote. Right, so the leading term in the numerator is x squared that is degree 2. In the denominator, the leading term is x squared. The leading term is always the term with the largest exponent. And again, that is degree 2, the same as the exponent. All right, so 2 equals 2. They have the exact same degree. And if I didn't say it, by the way, this is in your notes. So this is going to be the ratio of the coefficients. There's no coefficient there, so it's understood that they are both 1, which means the horizontal asymptote is 1. Let's find the x and y intercepts. And again, we'll do the shorter method. We're just going to set the numerator equal to 0, because a fraction equals 0 where the numerator equals 0. But now look what happens if we try and set x squared plus 2 equal to 0. We would have x squared equals, we'd subtract 2 from both sides, so that would be negative 2. We would take a square root of both sides, don't forget plus or minus, and this would be x equals plus or minus, oh, that's a negative number, right? Well, the square root of negative 2 is the square root of 2 times the square root of negative 1. We can simplify the negative 1, that would be I, but we couldn't do anything with the square root of 2. And this is a complex number, so there are no x-intercepts. Right, if you set something equal to 0 and get a complex number, it is not that something is not going to have an x-intercept. But it does have a y-intercept. Right, so here's our y-intercept. We just plug in 0 for x. We have y equals 0 squared plus 2 divided by 0 squared minus 0 minus 6. Well, the only thing left is the 2 and the negative 6. And that reduces to negative 1/3. So there is a y-intercept at 0, negative 1/3. So we've got 1 point so far. And we are going to need at least 7 because we've got 2 vertical asymptotes. Right? So let's just remember our 0, negative 1/3 and the vertical asymptote and horizontal asymptote, and let's put those on the next page. Right? And then we can we can find our table of values, graph our function, find the domain, and find the range. So I have no little boxes here. It's all right. We'll just write it out. All right. So vertical asymptote. Somehow it got erased on mine. Was y equals 3 and y equals negative 2. And actually, let me write those in a different color. So in color code, the color of the asymptote to the graph. So it was x equals negative 2, x equals 3. All right, so let's graph those. There's negative 2. Here's x equals 3. And our horizontal asymptote. Right, that was y equals 1. Oh, that's a little too high on this side, or a little too low on the other side. One thing I'm noticing, I'm not seeing that glitch that I was seeing on the earlier podcast. Y equals 1. All right, and so now we need our table of values. All right, so we need 2 values less than negative 2. I think we're going to be fine with just the 2 values, negative 4 and negative 3. All right, so let's plug in negative 4. We get negative 4 squared plus 2 divided by negative 4 squared minus negative 4 minus 6. Negative 4 squared is 16. 16 plus 2 is 18. And then negative 4 squared is 16. That would be, it's minus a negative, so it's plus. So 16 plus 4 is 20. 20 minus 6 is 14. We could have reduced that just to make it easier to deal with. So 18 over 18 fourteenths reduces to 9/7. So it's about one and a third, just a little less than 1 1/3. And negative 5. I don't know why I didn't put -5 first, a smaller number. It's all right. -5 squared plus 2. -5 squared minus a -5 minus 6. Right, so -5 squared is 25 plus 2 is 27. So this should be smaller than 9/7. And then, because it's heading, as x gets larger, the graph's got to go to the horizontal asymptote. So 25 plus 5 would be 30. 30 minus 6 is 24. That also reduces. Both divisible by 3. So that's 9/8. So 9/8 is smaller than 9/7. Right? And now we need 3 values that are in between the two vertical asymptotes. Let's use -1. We already know 0. Right? 0 was -1/3. And then we'll use either 1 or 2. I guess 2. Let's use 2. And then on the other side of 3, we'll use 4 and 5. Oh, wait. You know what? I put in -5. I forgot. It wasn't -3 and 3. It's -2 and 3. Oh, I could have used -3, which would have probably been nicer. Oh, well, let's use -3 as well. Sorry about that. That's what happens when you're just kind of glancing over at the graph there. -3 squared plus 2. -3 squared minus a -3 minus 6. So -3 squared is 9 plus 2 is 11. So this should be greater than 9/7. And then 9 plus 3, it's going to give us 12 minus 6 is 6. So this is almost 2. All right, that's all the points on the left-hand side. All right, the points in between. All right, so we already said -1. -1 squared plus 2 divided by -1 squared minus a -1 minus 6. So that's going to be 1 plus 2, that's 3. And 1 plus 1 is 2. 2 minus 6 is a -4. So that's -3/4. We have 0, and that was -1/3. So -3/4 is greater than -1/3, or less than, depending on if you're thinking about the negative. We need to plug in a value greater, one more value between the two vertical asymptotes. So let's use 2. Oh, I'm going to be a little bit cramped in here. You know what? I am going to move everything up, and then I'll have more space. Okay, you stay. Maybe I can get everything in. I wanted to finish this lesson in 1, so I didn't stop, but I guess I should have. So 2, that would be 2 squared plus 2 divided by 2 squared minus 2. I don't know why I put in parentheses there. Don't need it. It's not minus a negative, it's just minus 2. Minus 2 minus 6. So that's going to be 4 plus 2, that's 6. And 4 minus 2 is going to be 2. 2 minus 6 is a -4. So this is -3/2. And then we need 2 more values. 4 and 5, I swear, are it. So, and if we hadn't plugged in -5, I would be done. All right, so we have 4 squared plus 2 divided by 4 squared minus 4 minus 6. So that's going to be 16 plus 2 is 18. And then 16 minus 4 is going to be 12. Minus 6 is going to be 6. And this is positive. Wait, we didn't lose a negative. No, it's good. Yeah, that one is positive. Oh, yeah, because we're on the other side of the asymptote. Okay, that doesn't matter. I'm looking at that negative 3/2. I'm like, what? It's negative, and this one's positive. That's okay, because they're on opposite sides of a vertical asymptote, so the signs may very well be different. But this is a very nice number, equals 3. And we need to squeeze in one more. Let's do that. And squeeze in the 5. So we have 5 squared plus 2 divided by 5 squared minus 5 minus 6. That's going to be 25 plus 2 is 27. And that would be 25 minus 5. That's 20 minus 6 is 14. So it's almost 2, just a tad less. Let's graph our points really quickly. All right, so negative 5, 9, 7. So a little bit more than 1. Negative 4, 9. Sorry, this goes here. This goes here. 9 eighths, which is just a tad bit more. And then this one, 11 sixths is almost 2. Really, I didn't need all 3 of those points. So here, not going to cross the horizontal, not going to cross the vertical. In the middle there, we have negative 1, negative 3/4. We have 0, negative 1/3. So that's a little closer to the x-axis. And then we have 2, negative 1.5. So we didn't have any S1s in this graph. Instead, we had 2 U's. Oops, I'm putting it in the wrong spot. So this one is another U. So sorry about that. It would have been nice to do 1 S and 1 U. It was probably the one I cut out because it wasn't in the notes. Well, I'm sure we might see some in another graph. There we go. So that one is a U shape. It comes back around again. And then the last 2 points, we have 4, 3, and 5. That's a little less than 2. And so it won't cross the vertical, not cross the vertical, and it won't cross the horizontal again. And there we go. There's our graph. Pretty symmetric, almost symmetric. The domain is going to be everything but the vertical asymptotes. So negative infinity to negative 2, negative 2 to 3, and 3 to infinity. And then the range, let's look at our graph. So it goes negative infinity to, it's got a high point there of negative 1/3. I'm not 100% sure that is the absolute, that's the absolute maximum. So I'm just going to put a parentheses here. I guess we could put, because it does go through negative 1/3. This one is not as symmetric as that other graph. And I don't know why there's like a random line here. So it does go through it, so we'll put the bracket there. But the other graph was so symmetric. This one is symmetric, but not as symmetric. And then it picks up again at the horizontal asymptote, 1 to infinity. And there we go. End behavior, and that's the last thing we're going to do. Let's see how fast I can do it. End behavior. Hopefully you're getting really used to these. And I didn't put end behavior on the homework, but it's a good idea to be introduced to it. So f of x approaches 1, the horizontal asymptote, as x approaches negative infinity. F of x approaches infinity as x approaches the first vertical asymptote from the left. It approaches negative infinity as it approaches that same vertical asymptote from the right. It also approaches negative infinity as it approaches the next vertical asymptote from the left, and it approaches positive infinity as it approaches that asymptote from the right. And then, of course, it has to head to the horizontal asymptote as x approaches infinity. And that's it. All right? So on those, in the middles there, it could be U-shaped if it turns back around. And so notice that the value in the middle is in between those two values on to the right and to the left. That's why we know it's U. Let's just take a look at one where we have an S, just as a reminder, since we didn't see an S in this one. 2 U's. There we go. This was from the previous Nearpod. So notice when they go in a diagonal, like one. So as we look left to right, each one is lower than the one before. Then it's going to be an S. Those are the only 2 shapes on the centerpiece. It's either going to be S-shaped or U-shaped. Well, that's the end of my podcast. Sorry, this one went a little long, but thanks for watching and bye for now.